All right, y'all. This is Mr. Moon here from Lunar Math, and I have nothing better to do with myself right now. So I'm going to do some solutions to some circle problems, angles inside and outside a circle. The big two formulas that we're going to be using, and let me see if I can jot these down at the top here. Sweet. Okay, so our big two formulas are basically this. If we are inside a circle, and we are looking for this angle, let's call it x. Actually, let's not call it x because we're going to call something else x. Let's say we're looking for this angle and let's call it angle, I don't know, A. If we have an arc x and an arc y, then A equals x plus y over 2. If, on the other hand, we have a circle like this, where the angle goes through. This is going to be a terrible picture. Through the circle. So here's our angle B. We have an arc. Let's call this one X. And let's call this one Y. In this case, when it cuts off these two arcs, we actually have B equals X minus Y over 2. Okay, very cool. So what we're going to do is go back. Didn't mean to do that. Let's go back. There we go. To our first problem. Why is it zooming that? It's zooming that. Cool. So I'm trying to figure out how to zoom. What is it? Huh. That's fine, I guess. Yeah, that's what I wanted. Okay. So we are a little more zoomed in. Hopefully we can see these problems okay. Yeah, it should be good. So let's look at doing these. So we've got one down here. This is a case where we are cutting off the circle twice. This is going to be an x minus y over 2 case. Okay. In this case, our big arc, the x is 145 and the y is 53. So we got 145 minus 53 over 2, and let's see, 145 minus 3 is 142, minus 50 is 92, over 2 equals, looks like 46 degrees. This is going to be our answer there. And I'm going to stop there. I'm not going to go into, yeah, that's fine. So again, we have a case down here. Actually, let's look at number 2. So here we have, one arc, let's call that our x. Oh, this is the arc we're missing, in this case the y. And we have this angle labeled in the middle. So what we know is that 125 equals 50 plus y over 2. And remember, when the angle is inside the circle, we do the plus x plus y formula, not the x minus y formula. So what we're going to do here, this is going to require a slightly different strategy, a little more of a thinking backwards problem. So let's try multiplying both sides by 2. And I'll just demo this real quick. The real thing we want to get rid of is this 2 down here. So if we multiply both sides by 2, that actually should go away. I'll show you guys the results of that. We're going to get 250 equals 50 plus y. And hopefully everybody can kind of see where this is going, because if we subtract 50 from both sides, then we get 200 equals y. Okay, so y in this case is a 200-degree arc. Cool. And I should box that just so we have it. And let's look at the next one. So down here we have a case much like number 1, where we have this angle that's cutting off 2 arcs. Remember, this is going to be now x minus y, and we're actually looking for y. And x minus y divided by 2, which is going to be 190 minus y over 2, I should make it more clear that that's a 9, is going to equal 58. Again, let's try that multiply by 2 trick. So if we multiply both sides by 2, that should cancel those out, and we're going to get 190 minus y equals 58 times 2. 50 times 2 is 100. 8 times 2 is 16. So we got 116. I think I'm just going to add y to both sides, so that should give me 190 equals 116 plus y. That's adding y to both sides. The reason I want to do that is now my y is positive, which is kind of nice. I can subtract 116 from both sides. Let's see, 190 minus 116. So 190 minus 100 is 90, minus 10 is 80, minus 6 is 74. So we should get 74 is that y. Okay, so there's our second problem done. And let's look over, no, not our second problem, that was our third problem. Okay, and let's look over at number 4. So here we've got the angle up here. We also have the inner arc, so this is the one we're subtracting. We're looking for the big guy. So what we see is that 39, and remember this is one where the angle is outside, so we're subtracting. So the angle is x minus 80 over 2. Multiply both sides by 2. We should get, let's see, 78 equals x minus 80. If we add 80 to both sides, we get x equals 158. Very cool. Let's look at number 5. Number 5 is one of the ones where we get to add the angles, because the angle in here is, ooh, that was bad. The angle in there is inside the circle. Let me actually erase that, because that seems to, how can I make this bigger? There we go. That angle is just, that's a terrible label. So we have this angle inside, we have this angle outside, we are looking for the missing angle over here. So what we're going to see is that 126 plus, let's call it y, divided by 2, there's our formula, equals 103. Okay, we can multiply both sides by 2, we get 126 plus y equals 206. Hey guys, guess what? 126 plus 80 equals 206. So y has to be 80. Some quick math there. Let's look at this next one. This is going to be a simple average. So we've got, let's see if we can label this. We know that this arc is 130. We know that this arc is 50. So we've got 130 plus 50 over 2, and that should give us this angle in here, which we'll call A, and that's going to give us 180 over 2 equals A, so A must be 90, because 180 divided by 2 is 90. Very cool. Let's look at number 7. Number 7 is one of these subtraction cases. So we know the big arc is 118, the small arc is 40, and we're looking for this missing angle. So what we're going to do is 118 minus 40 divided by 2 equals this missing angle A. Okay, so 118 minus 40, that's 78 divided by 2. And that's going to be A. And if we whip out a calculator, we can see that A is 39. Very cool. Let's look at number 8. And number 8. So what we've got is this inner arc. We know that's 105. We do not know this outer arc. Oh, we also don't know this angle. So let's take another look at this outer arc, and I'm actually going to trace it in red so that we can see it. What we know so far is that this inner angle is 105. We don't know this outer arc, but we know that a circle is 360 degrees. So 360 degrees minus that small arc should actually give us that big arc, okay? And we're going to find that, and I'm going to label this a third time. We're going to find that if we subtract this, 360 minus 100 is 260. 260 minus 5 is 255 degrees. So this big arc out here is 255. And now we actually should be able to find A. So angle A equals 255, which is the big arc, minus 105, which is the small arc, divided by 2. 255 minus 105, well, 255 minus 100 is 155, minus 5 is 150 over 2, which is 75. Okay, so there's our answer, our arc there, our angle there, sorry, 75 degrees. Let's look at number 9. Oh, weird one. Okay, so we have 50 here. It is cutting off a small piece of the circle. We're actually looking for this one. Now, interestingly enough, this is an angle type that we've looked at before. This is called an inscribed angle. Now we know that an inscribed angle is half of the arc it cuts off. So if this guy over here is 50, this arc here must be 100, okay, which leaves 260 degrees for the rest of this arc, and I'm just going to label that there. Okay, let's look at this last one. Now here we have another great case of the subtractions. So what we're going to see is that the small arc is 71 degrees. We've got this angle labeled here as 53 degrees, and we have this big arc out here that we don't know what it is. So I'm going to say x minus, let's color code this, why not, 71, and sticking to the formula divided by 2, that's going to equal 53 degrees. Okay, now I'm going to drop the color coding because it's going to become a pain in a second. So let's multiply both sides by 2. And that should give us 106 over on the right side, and it should give us, if we cancel these out, x minus 71. Now if we add 71 to both sides, we should see x equals 177. So there's our big arc, and we're done.